Everyone, welcome back to my YouTube channel. Today we are solving Biweekly Contest 125 of LeetCode. I was able to solve the first three questions. We have already discussed the first two. Now we are doing the third one. So the question is count pairs of connectable servers in a weighted tree network. You are given an unrooted weighted tree with n vertices representing servers numbered from 0 to n minus 1, an array edges where edges I represent bidirectional edge between vertices A and B of weight. You're also given an integer signal speed. So we're given a tree sort of graph, but it won't contain any loops, or cycle. So two servers A and B are connectable through a server C if A is less than B and A is not equal to C and B is not equal to C, so they should be distinct, A, B and C. The distance from C to A should be divisible by signal speed. The distance from C to B should also be divisible by signal speed. Return an integer array count of length n, where count I is the number of server pairs that are connectable through server I. Suppose we take this example. This is the graph given to us, or the tree given to us. So we need not worry about this, as every path or every edge from a vertex would be unique if it doesn't contain any loop or cycle. So if we take this 0, from 0 how many pairs can we create which are of servers which are connectable and having this satisfying this condition? So from 0 we are only having one edge, so we can't form a pair, so the answer is 0. Now if we take these 1, from 1 one pair would be 0 and 2. From 1 I can reach 0 also and I can reach 2 also. Signal speed is 1, so 1 is divisible by 1, 5 is divisible by 1. So this is one pair, 0 and 2, right? And there's one more. From 1 I can also reach 3, so 0 and 3 is a pair. From 1 I can also reach 4, 0 and 4 is a pair, and all the distances are divisible by signal speed, that is 1. And from 1 I can also reach 5. So total I have 0, 2, 0, 3, 0, 4, 0, 5, 4 pairs. Now for 2 I can reach on left side 1 and 0, and here I can reach 3, 4 and 5. So if we take, I can make 1, 3, 1, 4, 1, 5, 3 pairs. I can make 0, 3, 0, 4, 0, 5, 6 pairs. Same for 3, I can make 6 pairs, 2, 1, 0, 4, 5, 3 into 2. For 2 I can make 4 and 5, 2 pairs. For 1 also I can make 2 pairs, 0 also I can make 2 pairs. And for 4 I can make only 4 pairs, 5 and 3, 5 and 2, 5 and 1, 5 and 0. So 4, and for 5 I only have one edge, so I can't make any pair, so it would be 0. Okay, now this one is a bit interesting one, as here we have vertex 3 which has got 4 edges. So now how we'll start this problem? The main intuition or the approach for this problem is that we'll take every vertex one by one. Suppose I take 0, and then I'll loop over all the paths that can be formed from this vertex. Like from 0 I can go to 0, 6 and 5. This is one path. I can go to 0, 1, 2. I can go to 0, 1, 0, 0, 3, 4, 0, 3, 2, 0, 3, 1. So these are all the paths I can go to. So what I'll do, from 0, how many paths I can make? I can make 0, 6, 3. This is one path. Now I'll also see when going through these vertices, what is the distance and are these distance divisible by our signal speed. So when I go from 0 to 6, the distance is 3, signal speed is 3, it is divisible. So I have one vertex which is divisible by. Now from 6 to 5, 3 plus 3 6, this is also divisible, so I have 2. From 0 I have on this path I have 2 vertices which are divisible by signal speed. Now from 0 I can also go to 0, 3 and 4. Now on this path, if I go to 0, 3, 4, 1 plus 1, 0, first I'll go to 3. 1 is not divisible by signal speed. Okay, we'll not consider this. So I'll go to 1, 0, 3 and then 4. 1 plus 2, 3. This is divisible, so 1. Now next path is 0, 3 and 2. Now if you see 0, 3 and 2, 1 plus 7, 8. Not divisible, 0. Now if you take 0, 3 and 6, 1 plus 6, 7. Not divisible. So 0, 3 and 1. So this is 6. 0. No paths that have their distances divisible by signal speed. So for this 0, so for this 0, I have got 4 paths to the leaf nodes or the vertices, and which have the counts of the distances divisible by signal speed as 2, 1, 0 and 0. So now what I can simply do is, on this path I have 2 vertices that are divisible by 0. On this path I have 1 vertex. So in this case I can make 2 pairs, right? From this and this I can make 2 pairs. If you see in the graph, 0, 6 and 5, I can make, this is one path and this is one path which have distances divisible by signal speed. So what I can do is, keeping center as 0, I can make one pair as 6 and 4, 0 to 6 and 0, 3, 4. One pair can be 5 and 4, 0, 6, 5, 0, 3, 4. Yeah. So suppose for any random vertex I get this count array as 1, 2, 1, 2. So this vertex has 4 paths. In the first path there is only one vertex whose distance is divisible by signal speed. For the next we have 2, for the next we have 1, and for the next we have 2. So now how many pairs can we form from this count array? We can just do brute force directly. From one of this vertex I can make 2 pairs with this, 1 pair with this, 2 pairs with this. So 5. Plus I'll take this one, from this to this 2, this to this 4. Now from this third element, 1 into 2, 2. So I can make around 11 pairs. So that's how we start this. If you see the code, I'm just creating an adjacency list just to maintain like what are the edges to which vertex one vertex is connected, and I'm also maintaining the weights. So I've taken a list of list, and then itself is a 3D integer array, if you can relate to it. Yeah, so I have created this adjacency list. For 0 I've added 6 and I've given this 3 weight as well. For 6 I've added 5 and I've given this 3 weight as well. Yeah, so what we'll do, I'll loop over every vertex. I'll find out that how many edges are connected to this vertex. If it has only one vertex, so then it can't form pairs, so we'll just continue. Otherwise, for every edge we can make a unique path. So I'll create an array, and now I have taken this global variable sum. I'll turn it to be 0, and then I'll pass this, suppose I'm taking this u as 0. This is my center element currently, so I can make 6 so I can make 4 paths from it as I've shown here, right? So one by one we loop over every path, right? So what I'll do is, I'll just pass it to our function fun, and it is simply and along with that, while passing, I'll also pass the sum. Like from when I'm passing it to 6, I'll pass the sum as 3. So in this fun function, what I'm really doing is, I'm checking if my sum so far is not equal to 0 and it is divisible by our signal speed. Then I'll directly do sum plus plus, that I've got one vertex which is divisible by our which is divisible by our signal speed. And then for this 6, I'll move on to the next of its neighbors, just to see if we are able to find more vertices on that path. So I'll just go to the adjacent elements of that 6, and I'll also add the weight of that element. This way I'll get all the elements to which I can reach, and the distance is divisible by signal speed. Once I've got this sum, I'll put it in ARR, and then in ARR I'll just do the brute force. By this brute force I can get all the pairs, and this will be in my result array. So if we just try to submit it, yeah, works fine.